Cool. So, welcome everyone. So you may need to switch on the guys. So let's continue. Thank you, by the way. So you may want to switch on the monitors too in order to see a bit more. First things first. So I got repeatedly the questions about the assignment and similar questions. So I think I did a bad job in explaining it in the first place. So what is the assignment about? So let's try to get it together. So see if we have a shared understanding of what the assignment is about, assignment 2. Okay, who read the instructions? All right, one person, that's pretty good. I assume it's more actually, but let's take it. So what are you doing for assignment 2? It's usually quite important to get a good understanding of what you're planning to do before you're actually doing it. Otherwise, you kind of end up in a uncomfortable place, most likely. Anyone? Yep, please.
Register webhooks and collect the data about currency and post to the webhooks that are registered.
Cool. So yeah, that's exactly right. So, but how does it work? What are you actually building?
I'm building the service that you can post webhooks to and regularly invokes the webhooks.
Cool.
And collects the currency data and just caches it.
Right. So that's what you're building, right?
Yeah.
What is your service consuming something?
Yes, data from another service,
Yeah.
the currency API.
Yeah. So from the currency service, whatever that may be, doesn't matter, exchange service exactly. So you're consuming this thing, you're getting currency data mostly, right? So are you providing services to someone else?
Yes, to the user that posts the webhook.
Yeah. So the user posts the webhook, right? Or we thought about the
edits or whatever.
Sorry?
Or
Yeah.
edits or
Yeah. So, and the idea was there that the user registers the webhook with the server, right? So what's the payload like?
it's the target currency base currency, the webhook URL.
Yeah.
That's to the another.
Target. What else?
Minimum and maximum trigger values.
That's right. So minimum and maximum trigger value for a particular currency, right? For exchange rate particular, right? Cool. So that's what you're registering. So what does that service do with that information?
Invokes the webhook to the remote URL.
Just keep going.
Invokes the webhook at the remote URL and posts the currency data when the current currency value goes over the trigger value.
Right, exactly. So so it invokes actually the URL, whatever URL you have given the service when registering is invoked if one of those conditions is met, right? So that your currency exchange that you're receiving from external service goes below specified values or above the specified values. So you simply invoke the URL that has been specified. It may or may not be the service, the entity that has registered the webhook, but anyway, you're just invoking that particular URL. What's the payload like? It's kind of open to everyone, so I feel like I'm.
It's
okay.
about the same, just containing not the remote URL, but the current currency value instead.
Oh. Right. Target, current, min, max. Sure. Right. So that's the thing. So that's invoking the webhook, right? So every time you see invoking, registration, invocation. And what is the backend we're using to store information?
MongoDB.
MongoDB, right? So you have some sort of database service that sits below here, and you actually use that to interact. So that's your way of dealing with state, right? Because you need to assume that Heroku or whoever else shuts down your service potentially, or not, whatever. Cool. Does that somehow make sense? Open questions, totally permissible. Yeah?
So a tick, is that whenever you draw information from the other service? From the currency side?
What do you mean?
In the description, it says something about the last tick from, I think it's like line 3 or something, line 2. No. The system will allow the user to query for the latest ticker
right.
of the given currency.
Yep. So so that should be So that's an additional path you can access, right? It's path from registration. You can also simply inquire about the latest ticker information in your service. So it kind of needs to relay that.
So what do you mean by a ticker service?
Oh, well, sorry. Yeah, okay. Ticker service means really give me the current exchange rate.
Oh, okay.
So yeah, it's a bit of slang there, I admit. So it's basically just give you the latest value for that particular base currency, for the exchange rate for base currency and target currency. That's all it means. Yeah. So so that's all. This is just terminology there. So sorry for that. But it's literally the ability to inquire about the latest exchange rate for the particular currency pair and the average across past exchange rates. Yes, but the main challenge I think is dealing with this invocation. That's the key idea. Yeah. Anyone else? Thoughts? Worries? Okay, still have 9 days anyway to submit. I think next Thursday, isn't it? Not this Thursday? Yeah.
Something like that. I have noticed that fixture IO sometimes is really slow and sometimes just times out. And don't know if anyone else has that problem.
Right. So,
both using just the normal browser and using Postman.
Right.
Sometimes you just need to try several times before I actually get the result.
Yeah.
Like get the JSON structure, find out how I need to program.
Good. So okay, that's good information. That's valuable to bear in mind. What we will do is probably think about using consider the outage when we evaluate your service. We consider the outage of Fixer.io by monitoring it as well. So it will be our way around it. For you, what would it mean? How would you deal with it now then? What would be your approach to deal with those issues? Unreliable web services, or the fact that you're programming on a plane or without internet? So how would you deal with this?
Mocking.
Sorry?
Mocking the service.
Either basically mocking the service by taking or getting, once you get it, one JSON actually stored in a text file, and then have some sort of mock service that listens on that particular path. You obviously need to adjust the URL then, and just blindly produces the JSON content that you expect from the fixer until you have a stable service, and then you let it loose on the production system, on the actual service. So that would be a way around here. But I think that's always a problem.
And you could also use the API because I think it's just openly available for everyone, so you could run your own version of it.
Okay.
Locally or.
Sure, if that's always an alternative, but you wouldn't want to expend a massive amount of time just setting it up, right? So if it's a quick solution, that's an option. But generally, caching a web service is not a bad idea, especially since you have, I would say, infrequently changing data. Yes, they change, but I think the information changes once a day or something like that. So you can really cache it and just blindly work off it and see that your service does what it's supposed to do before you use it on a live service. Does that make sense?
So the service gives the average of the last 7 days. Does that mean the service has to have been up and running for at least 7 days before you test it, or can you fake it somehow? You can request back in time. Okay. So what I do is I cache when I search for all the currency information from one date. I go through my own database and check the last 7 days. And if one of them are missing, I go and fetch them from the API.
Well, that's advanced, okay. Yeah. So, yep, so that's the possible strategy there. Yep. Cool. Other thoughts? Still have a week, so it's not deadly. But as long as it is roughly clear what's happening in terms of architecture. Yep.
Have you done an implementation?
Sorry, what?
Have you done, I was just wondering how many lines of code you're estimating will be when it's completed?
Good question. No, I would be a moderate to wild guess right now, so no, I'll avoid that. But frankly, it shouldn't be much more than the first service. This is more, but what are the only things you need to consider now? Mostly the additional aspects that you need to consider in this version of the service.
Interfacing with MongoDB.
Yeah.
And we did call an external service last time too, so.
Yeah, that's similar. So you simply have more endpoints you need to service, but other than that, it's really mostly the interaction with MongoDB that is the tricky bit.
My tests, though, are taking up more than half of the code base right now.
Oh, that's reasonable.
Okay.
That's entirely reasonable. In fact, you would expect that because when you test, we briefly talked about mocking, you're kind of creating a contained environment around your service, right? So you need to kind of think about this thing here, the exchange information service, currency exchange service, and obviously the client as well. So you kind of need to ideally simulate and emulate the entire environment around it. So it doesn't surprise me that you need to have possibly the same amount of code just for tests. That's absolutely reasonable. That's the difference. I mean, if you have a standalone service that you, for example, only invoke from a client side, it's a lot easier. But here you really need to deal with a lot of interaction. In fact, like at least three interaction partners you need to be dealing with. So plus you need to mock up sample data, so which is also a bit of an additional overhead. So no, it shouldn't be too surprising. But it means that you are taking the right approach. Do you do testing first and then building against it? Okay. Testing development. Okay. Cool. Other thoughts, worries, questions? No? Okay. Right. Cool. So, what did we talk about yesterday? Coming to a nice, new, interesting topic, or not so interesting, depends. Matter of perspective. Who recalls anything? There was a lot of talking yesterday.
Talked about like local networks and certain tasks.
Ah, cool. Okay. Right.
For example,
That was.
routing between nets.
Yep. So we talked about this thing, which was rather sketchy, admittedly. So it's rather doing networking in a nutshell, in a very weird nutshell. But I hope you got understood the essence, or not. If not, is anyone totally lost in terms of networking? I may have confused people. No feedback is no feedback. I need feedback. I thought there's some living souls in here. I'm not sure where they are. I'm still scouting. Whatever. Okay, networking. Okay. Well, the course is not core about networking anyway. But what else did we look at? Anyone? Open question.
Platform as a service,
Yep.
infrastructure as a service.
That's right. So infrastructure as a service concepts, right? So that we're actually operating, running infrastructure. So what's the key difference to platform as a service? There were some aspects that we discussed that are relevant. The floor is yours, not mine. Just to clarify that. Do we need to start from the beginning or what? It's probably not helping, right? So yeah, please.
have more control over the operating system and environment variables that
Yep.
you can control them.
Yep. So you basically operate on a lower level that includes operating system. What are the other two components that are probably worthwhile considering?
Users and groups. Or like
All that stuff. That's all operating
Yeah.
system. So what else do we probably need to deal with?
Oh, perhaps networking.
Networking,
some
right?
part of it.
You saw us mucking around with this, yes. So yep. And what else? The last thing.
Security.
Yeah, that's like a cross-cutting concern that affects all of those issues, right? So security is, you're absolutely spot on. It's always a concern when we think about cloud computing, specifically infrastructure as a service, because you're responsible, right? So it's no longer Heroku doing it for you. You are kind of responsible on multiple levels, right? Operating system as well as application level, right? But there was one other aspect. So we have computing, networking, and I had the impression some of you were here yesterday. I'm not sure anymore. No? Yeah, please.
Operations, because you have to control multiple machines, or
Again, that's a bigger picture thing. That is like because you do that, what I'm looking for, you can do that what you're mentioning right now, right? So since you virtualize the entire environment, you can replicate, duplicate it, scale it, and so on. But you need to virtualize computing, networking, and ultimately storage as well. So storage is the third component that's also managed. In Heroku, you don't really deal with storage explicitly. Even if you're invoking or using an external MongoDB service, you're not kind of really dealing with storage. You're just using yet another service, and it happens to keep track of your data. How they do it internally is nothing you can actually control, right? So bearing those in mind. So we briefly looked at OpenStack because it's running, and you guys should all have access. Did anyone try it? Just
I didn't get access, but that
Okay.
might have been because I don't know exactly what to write in and such.
right. Let's go back to that one, because I would like you guys to have a opportunity to explore that, to get a feel. So you go to, I think just typing skyhighhic.no in HTTPS with HTTPS should redirect you to a login. I'll just try it again. It should it gives you a redirect. So skyhigh.hic.no, and just write it on the board. Right, HTTPS, cool. Should redirect you to login page. Yeah, better? Cool.
Yeah. Yes.
So domain is NTNU, right? So that's how you guys are affiliated, and it's linked to the training login anyway. So that's why they need the institution as a context, domain, and then your username and password should be all the same that you usually do, right? So is anyone there who has tried it and failed, or I mean, not the people that didn't try it? That's fine. Good. So else we need to debug it and talk to the administrators of that. Cool. So that's OpenStack. You just log in, and we basically ran through the networking part of the setup and just barely got an instance running. I'll tear that down as instance just to have a comprehensive overview of how to set it up in the first place. So yesterday we set up a test instance. I will delete this one. Shouldn't be too painful. Let's see. One thing that's quite interesting if you do that, that you notice, because it reflects what we talked about, processing versus storage, is even though you deleted the instances, the volumes may still be there, right? So the actual data, the storage is still there. You could create a new instance and attach it to the existing data container here, right? So that's the, or volume rather, that's the term of choice. But I'm deleting this one as well. What I'm not redoing is the networking, because I think we had that reasonably comprehensively set up. So, and that's also a thing you generally only set up once. I mean, it depends on your objectives. You run multiple environments there, but for our purpose, it will just be that we have one network that we're using and connecting our VMs to, right? So we're mostly interested in the computing bit. One thing I will run through with you, since we have a bit more time now, is the creation of key pairs. Yesterday, key pairs. So that's quite essential, because you will need to do that for any of the big services. So whether you're running DigitalOcean, AWS, Azure, OpenStack, they generally don't allow you to log in via username and password. You will always need to have the pre-shared, or no, you need to have a public-private key encryption authentication, right? So because that's the SSH protocol, it's the way it basically operates. So you have a public key and you have a private key. The public key is owned by that particular instance you're dealing with, and you own the private key, and only you can basically authenticate against the SSH service with a given username, and that will give you access to the instance in question. How do you do it in OpenStack? Quite straightforward. So you can either import pairs, but generally it's probably easier just to create pairs. So you give them a name, another key. It will be created in the background for you, and then you just download it. Another key. So obviously you need to keep this secret somewhat, because everyone with this key can access your virtual machine, right? Given that they know your IP address that you will have. So cool. Let's do that. Good. So now we have basically the a key created. Doesn't mean we used it yet, but we get to that in a second. So now you see another key here. So that's all good. Yesterday we briefly talked about security groups. Again, security groups. What is that? What does a security group do? What do you specify there? Yeah? No? Anyone? Well, yeah.
What the group is allowed to do?
Yeah. In what? Yeah, that's right. In what terms allowed? How more specifically? What? Because you manage rules, right? What kind of rules do we manage there?
Which commands, I assume?
Not quite. What quite? We're not constraining the user's operations on the, let's say, in the virtual machine of the operating system, but what do we actually contain or constrain?
Manage rules for network traffic. Network communication.
Yeah, that's right. So it's basically your firewall rules. Yeah, something that you would need to set up in your own local firewall. It's not set up on VM level, but it's basically set up by security group level. So it's basically a container around your environment, around your instances, or your instances, that allows you to flexibly allocate different security groups, but also quickly change them. For example, you have 10 VMs that serve roughly the same purpose, which is to serve a web page mediated by a load balancer, and you want to change the rules or the services that can be accessed on those services, on those virtual machines. Then it's just one change in a security group away, instead of going to 10 machines and changing it all individually. Yeah, so it's a separation of security, somewhat outsourced from the operating system to the cloud environment, right? And yesterday we set up additional rules. So generally the rules look like this. We have a direction of traffic that we want to control, right? Egress means outgoing, ingress ingoing. We have a type of network protocol that we're dealing with. So in our case, it's IPv4 and IPv6. Generally more IPv4 for our use case here. And different IP protocols. We know two of them. Which ones were they again? Yesterday someone mentioned them. There was something? Yep.
TCP and UDP.
TCP and UDP, right? So for different purposes. What's the difference between them? Open question to everyone. When you use what?
UDP doesn't really care if it comes to message.
Yeah, exactly, right? So it's really just fire and forget, right? So you just send a message and hope it arrives eventually or not. The application needs to deal with it whether it actually arrived or not, whereas TCP is doing that for you. Advantage, disadvantage? Yes, it's like fast like hell, UDP, because you blindly send, you don't wait for confirmations, you don't resend packages, so you just blindly send and it makes it significantly faster. That's right. Cool. So what do we allow? We allow any outgoing traffic via IPv6 for any IP protocol or transport protocol across any port range. So this service or any VM that sits behind this security group can do anything internet facing, right? So it can, any outgoing traffic is permitted, and it can also access any sort of server. That is basically the representation of wildcard in IPv6, so it can access any sort of IP address that you can think of. Yeah. So same for IPv4, it's quite straightforward. What we added was the rule for incoming traffic, because we want to run our VM as a server as well, right? So right now, if we only have egress rules, it basically just means it's acting as a client to something, right? So which works. The firewall is clever enough, it's stateful, meaning it actually will technically also route incoming packages, but only incoming packages that are response to an outgoing request. Yeah. So if you send, for example, an HTTP request technically from a particular client, then the security group and the firewall behind it will track this connectivity and realize, oh, the response from a server is actually response to the request, and therefore route it back to the VM behind it. However, if this VM is a server, like a web server itself, it will never receive any request traffic, because incoming requests will be blocked, yeah, by default. So you need to open up or specify a corresponding security group. So in this case, what did we open up here? And why? Anyone, please? Yep.
Something to connect with the SSH protocol.
Yes, exactly, right? SSH. We only focus on IPv4. It's a TCP-based protocol because it requires a reliable connectivity, and it operates on port 22 by convention. You can obviously, well, for security reasons, you may change the port actually, but by default, the daemon runs on port 22, and connectivity from everywhere is allowed. So those were the rules we set up. Again, those security groups are independent of the instances. I just want to run through those to give you better understanding, hopefully. Anyway, so let's come back to our instances and create yet another one relatively quickly. So we have a given zone. We only create one instance today. We have a we start off with an image, ideally. I think yesterday we used what is it, 1610 LTS. I think nearly months ago, I talked about the difference between normal Ubuntu versions and LTS distributions, right? Does anyone recall the difference? Yeah?
Time support.
Exactly, right? So if you're running a server, you kind of want to don't want to repeatedly or frequently reinstall it, right? It's particular a consideration in an infrastructure as a service environment, because you need to manage the operating system. So it's probably better to use long-term support distributions, because they usually get support for up to 5 years. So it means you can just blindly run this and run updates on it, as opposed to reinstalling the entire operating system, right? So that seems to be reasonable. So we take one of those and see that this is basically now the underlying image that we'll be using. So you can select from the available. You can also create own ones and upload them into OpenStack as well, right? So it's something to bear in mind. And then we need to obviously, now after having thought about the storage bit, we now need to look at the processing bit. And that's called flavor here. So we need to pick a flavor that fits our needs in terms of how many virtual CPUs do we need, how much RAM, and how much disk we want to allocate to a system. So yeah, so again, you have a quota of for all those elements here that you can actually use for resources, disk, RAM, CPU, and so on. So you need to be mindful in terms of allocating that cleverly. So we chose one particular instance here right now. Networking is straightforward. Since we set up our network, we just reuse it. It's allocated by default. And we're not caring about additional network ports. So you could have additional network ports on that machine, but we don't do that. We just stick to the ones that link us to the main network. So security groups, we don't want the default group because it doesn't allow SSH access. So I will just remove that. Yep, and add the SSH one instead. Key pair. So we need to decide which of those keys that are here, for example, should we be able to use to authenticate against the machine. If you don't import a key pair, you won't be able to access it. You won't be able to access your machine unless you have an image that allows you to log in via password. But the default images don't do that, and it's bad practice in the first place. So you won't get too far. So we need to pick one. Let's pick the key we just chose, another key. And this basically will inject this particular key into your instance once it's created. So you should be able to authenticate against this afterwards. Cool, additional configuration, so you can customize instances upon instantiation, but we are leaving that. You can also do advanced partitioning. Okay, didn't try that out yet. Assign it to server groups. So for example, you may have a stratified system where you have web services, database services, etc. So you can manage them as individual groups. Yeah, so for the management point of view, it's easier to do that. Can customize scheduling, we're not caring about this, or additional metadata for the system. So now we're launching the instance, so it should create the associated storage from the image, it should create the instance, and it should link the instance to the underlying network. So those are the three things that are happening now, basically. Takes a bit, but will eventually work. And the longest, the part that generally takes the longest is the creation of volumes. We also see that it's similar to yesterday, got assigned a IP address. So again, the network has DHCP enabled, which means that it's dynamically allocating IP addresses from a pool of IP addresses in that subnet that we specified. And this one gets one as well. So perhaps we can also already look at the network topology. I'm not sure if it's already there. Yep, that looks good. So again, we have the test network here, this 192.168 prefix 16. And we have a test instance here that's connected. It's still building right now, but nevertheless, we see now the network topology. So we're technically connected to the external network, which is connected to the internet, so we can actually do meaningful stuff on it. I think there's also a hyperbolic graph that self-organizes, but it's not really particularly helpful for our mini network, so it doesn't really add any value right now. Cool, how are we doing here? Instance, yep, we're getting somewhere. Cool, while this thing is doing this, we still need to do something else in order to gain access. So here comes the bit more of a tricky bit, because we need to be able, obviously, to import the private key, which was generated earlier, but we need to consider here sky-high specific aspects. So you will not be able to directly access the VMs from the NTNU network, because they sit in their own private network or own subnet. They are only accessible via sky-high itself. It serves as a jump host. There are ways around it, but technically we need to use it for now. So what all of you will actually have is hopefully a login to sky-high. So if you're using Windows, yeah, it's a tool called PuTTY. Does anyone know PuTTY? Yep, cool. Anyone else? Yeah? Most people know PuTTY somehow. Why? From where do you know it?
I have fagbrev in computer electronics.
Okay.
Use this to configure switches and stuff.
That's right. Yep. Cool. That's very commonly used. In Cisco courses as well, they tend to use PuTTY quite a bit to do that. That's right. Yep. The rest similar from networking mostly, or?
Well, we used sky-high in databases and applications class.
So everyone is. Does everyone have that background? So you did advanced paper already, right? You're a bit ahead, is it? You're
well, I'm a third year, so.
Cool. Okay.
Yeah.
Sweet. Okay. Sweet. But the rest hasn't seen PuTTY yet, and hasn't. Yeah. Cool. Okay. Just to clarify, I don't, because always stop me in case you all have seen something before, right? Because I may not know what you have seen before, right? So, but that's cool. Thank you. Sweet. So what we need to do is to actually log into SkyHigh. It's a bit tiny, and I don't know how to increase the font size in Putty itself. What I'm doing here, I brought Putty up. This tool, by the way, is freely available for download. Use the official site to download it, because there are sometimes some dodgy secondary sites that may provide you with modified versions, since the sources are freely available. So that's the tool. Basically, it's frequently updated, but it's relatively secure, and it has been developed by Simon Tetham. So if you find anything else, then it's most likely not the one you're looking for. Is that? Yep. And that brings you to a reasonably straightforward site, but it's available for many operating systems. There are many other additional tools that basically translate Linux tools into Windows. For example, PSCP is a variation of the Linux tool SCP secure copy that you can use then on Windows as well. Anyway, back to Putty. So SkyHigh hic.no on port 22. And when you open it, now open in my main window, I bring it over here, you will need to log on using your credentials. Hang on, this one. Cool. So and then you are basically on SkyHigh itself. So SkyHigh is now an intermediary service that acts as what is considered a jump host. Yeah. So it's your way of getting to the actual VM eventually. So without this, you won't be. Assuming no further complications, you won't be able to access it. So there's another tool you will need to use, and that's called WinSCP. You could use the command line version, but for sake of convenience, in Windows it's a lot easier to use that tool. So that roughly looks like this up on login. So you have similarly, you identify the host name, you have a username, password, and port 22, because it operates via port 22 as well, via SSH. So SSH allows console access, but it also allows you to do FTP style interactions, so file transfer. So which we are using this one for. Searching the host, hopefully connecting. I need to enter my password. Is it visible? No, it's not. Good. Right. And cool. More critically then, yes, that's the one. Yeah, there. So and what you see here is my home directory. So on the right you see my home directory on SkyHigh. It's very tiny. Sorry for that. It's /home/CRE-France, whatever. So you will have yours as well. So that's on the Linux machine. Left side is in this case your Windows machine as well. And then you basically just copy that key over in this particular case. And then you should have access to it on Linux. So if I run ls here right now, you see another key is available. Cool. Yeah. So those are the steps you want to do. You access the intermediate jump host, skyhigh.hic.no, copy the private key, and then we need to do a few further things. So right now I'm just running you through those steps here. So those are the tools you need in Windows. You use WinSCP. In Linux, you can use SCP out of the box, which is more convenient. You just say SCP, then identify the private key file, and then log on to SkyHigh or point to SkyHigh using this username @skyhic.no : and then followed by tilde, which basically means on SkyHigh, log on with your username and point to the directory home on that particular machine. We'll ask you for your password and just copy the file, right? So it would be the equivalent there on Linux. So the only thing we need to do still is to change the permissions, because in order for those private keys to work with SSH clients in Linux, the system insists that only you as the owner have access to those files. So ironically, if the permissions are too permissive, meaning if others can see your private key, then the system will decline its use for security reasons. We'll just say, well, most likely your private key is not secure anymore, so I don't even allow you to use it. Yeah. So and the idea is here that we're just changing a permission set. What does chmod 600 do? What's the permission set afterwards if I run this? Okay. Since it's before the exam, wild guesses are acceptable.
I'm guessing super user?
You're guessing super user. Not quite. What does chmod do? Does anyone recall?
It changes the permissions to run, read, and write the application.
Right. So those.
Or a file, open the file.
And this specific 600, what does that do?
Owner can read and write.
Owner can read and write. That's correct. Yeah. So again, it's read, write, executes for different user types, right? So we have user, group, and anyone else, right? And the object representation reflects that. So in this case, we have read and write, with read being a value 4, decimal value 4, and write being 2 equals 6. So we can read and write to that file, but no one else can do anything. So that's why it's 600. So we just run that command on that particular file. So chmod, another, hang on, 600, another key. Cool. So now if you look at the permission set, we should see another key has the, yeah, 600, read and write, nothing else. Cool. So now let's see how far our system has progressed a bit. Going back to OpenStack. Cool. At this stage, it should be running, should be ready. So now we're nearly ready, but we're not quite. So volume is created, instance is created, but you notice that the IP address still points to a private IP address in the network that we created. So we can't really access it from anywhere outside of OpenStack, even not even from the jump host right now, because it's a private network in there. So the idea is there's a concept of what's called floating IPs, and those floating IPs allow you to access individual hosts from outside the boundaries of OpenStack in particular. Yeah. And we need to attach one of those. There's a pool of them. Each of you will have a few available that you can use. So basically you have a private public IP. That's not the right term to use, but you have a IP out of the pool of OpenStack IP addresses that you can use to access it from the jump host. Otherwise, you're constrained to your own private networks within your own VM environment. Yeah, cool. So we need to get a floating IP. So we use it from that pool. So you see that there's my quota. I have 50 available IPs from the pool from the external network. It means it will allocate one IP of that external network, which means it makes it available, makes my machine available on the external network, meaning via jump host or possibly even the internet. So depending on if we were to use tunneling, which we're not. So you select the pool external net, and you just click allocate IP. It picks one random one, or not random, systematically, but not something you can control. Generally, IP address, you allocate it to a particular instance. In our case, we have one instance with one port. Note that one instance could have multiple network interfaces, and then you associate it. So, and once you did this, I think we should be fine. Cool. So you now see here there's an associated floating IP address. Good. So in order to connect to that, let's go back here. And now we should be able to use our private key file. So on the jump host, we say SSH-I implies that we are using our own key file. What's the key file? It's another PM, yep, another key. And then we need to have username at IP address. So we use the floating IP address, which happens to be 172.16.1.186. So 172. So anything particular that you notice there in this command? No?
Well, it's a local, it's a local IP address, not an.
Yeah, that's right. So it's an IP address that is linked to OpenStack. That's right. So, but that's what we got. So we deal with it. No, the thing I want to point is the username. It's Ubuntu, right? So, and that boils down to the specific setup of the image on the server. So the username is fixed. For example, by default in AWS, Ubuntu instances have the user account Ubuntu by default as well. So it's quite important to know. So it doesn't really necessarily imply that you have a dedicated individual user account, but rather that you have a key that you're connecting with. Yeah. So cool. Now we are on that instance. So we are now actually. I have config just checking. Network instance. Yes. So that corresponds to the instance we're dealing with, and we can expect the capabilities we're having. So we have 512 megabyte RAM, I believe, here. So one user logged on, so not much going on. So now we have our own instance that we can then freely use and install Go on it or Git on it and actually use it and interact with it. So that's the key idea I wanted to get across here. So one of the aspects you could possibly do is, for example, deploy your assignment or an older one or a newer one on this particular server and test it. Note, please, the constraints we're having here are that it won't be easy to access it from outside the or from within the NGNU network. We could possibly organize public IP addresses, selective, from the SkyHigh team. But realistically, you're probably more constrained to within your project environment. But you could create multiple instances that you could use to mutually access the respective other instances. So, for example, you could run a Windows instance if you wanted, even as part of it, and a Linux instance to test your services. So it's not super convenient. It's more erring on the side of safety and security, admittedly. So, but that's the way it works right now in that system. Cool. Any questions? Probably run an update here, see what happens. Any question? No? Cool, sweet, quite straightforward tutorial, that's it. So it's on the slide set, so we shouldn't have any, see how outdated they are. Well, they need a bit of updating. So it's probably usually the first thing I'm doing when I have a fresh image just running update upgrades just to ensure that the latest packages are installed, because again, it's theoretically exposed to the internet, which makes it kind of challenging. Cool. Let's take a 10-minute break. So 15 past 12, we'll meet back here. And instead of starting Docker, which may be a bit too involved right now, I thought about running you through some AWS services to see what they offer and what they use, to get you more intuitive feel. It's simply not enough to start with a fresh new topic right now. So, and then.